Hello, my name is Joseph Suhr, and today I'll be talking about our second project in ME 3210, Design and Manufacturing. This project is looking at a field of expertise in design and manufacturing that I would think I would like to be an expert in the future. For this project, I chose computer-aided design as the area of expertise I would like to master. And this kind of includes the use of computers to create both 3D and 2D part models. This is really good for enabling precise visualization of parts when putting them together in an assembly to create an entire product, as well as the optimization of parts for different complex systems. This is something that I have personally used a lot, both in academia as well as in industry, and it has a lot of powerful tools and operations that kind of aid in all of the functions of engineering, especially in the design of parts and products. So looking at some of the applications, the biggest thing that CAD allows us to do is parametric design, which is basically linking dimensions together. So this involves shrinking of some dimensions and altering them so that way you can resize parts as needed, and models update automatically so that way if you make any changes, it is all done for you. Another thing is for 2D drafting of parts. So if you have a 3D part or a lot of parts put together in an assembly, you can create 2D drafts of them, which help with machining and fabricating. So that way, if you have to make these parts, and custom make them so that way they can all fit together for a desired function, then um, they can all come together with the drafting and a very powerful tool for that. Another thing that CAD software allows for is simulations, things like fluid dynamics, used for FMEA analysis. Basically, these simulations are used to validate the performance of the part before any physical parts are made. So this can be used to save time in the long run as well as money and other things spent on testing the product. You can run simulations to see if it's going to work at all. So the software also has a lot of connectivity with CAM or computer automated machining and manufacturing. This kind of works similarly with the 2D drafting of being able to quickly fabricate parts for prototyping, testing, whatever it may be. Now, some of the trends in early CAD. So CAD kind of goes back to the 1960s, where it really revolutionized early manual drafting. And kind of the biggest thing was this parametric modeling. So it avoids a lot of repetition that is caused from manually drafting and creating designs on paper. Then going into the 80s and 90s, you kind of get better visualization of parts. You get more more complex applications where you can kind of get a much better idea of what the parts are and the analysis of them as well. Going into the 2000s is when you kind of get into the simulations. And the bottom right is example of a CFD or computational fluid dynamics of a part, which is sort of in the more powerful aspects of what CAD can do. Moving more into the 2010s, you kind of get cloud-based CAD, so you can share parts with other people. You can work together and kind of have that collaboration as well. And then also additive manufacturing. This kind of goes into rapid prototyping, going directly from a 3D part to a prototype and being able to see how the part works and everything like that. What does current CAD do? Applications in some of the industry. So aerospace, you have innovative product design as well as aerodynamic simulations is very powerful for that. Construction, you can simulate structures and kind of efficiency. But also something that I found interesting is that you can even use CAD for different topographies. So if you are trying to create construction on a hillside, in a river basin, things like that, you can use CAD to kind of map the topography and see how your construction is going to fit in the real world. Healthcare, things like prosthetics, 3D printing, you can have replacement tissue, replacement organs. Um, all done with CAD software. Automotive, more prototyping. Manufacturing is also, you can use modeling and quickly fabricating parts as well. So kind of the basis of what current CAD is used for product design and really visualization of parts, and early scale simulations. Um, and about the future of CAD, so AI is kind of a big thing, like being able to integrate AI with these simulations, is going to shorten the CAD prediction time. So if we can use deep learning to kind of notice trends, then the amount of time it takes for the CAD to predict how a model, how a part is going to respond to the real world, we can use that to kind of shorten and quicken how we're able to do that. Optimization is another big one, which kind of goes back on knowing how things work, knowing, what's going to work, what isn't going to work, and optimizing how the part looks and how it works in the real world. Also creating predictive models kind of in that same vein of we can use what we know is going to happen to predict what we think will happen. Another interesting one that I found is VR integration, and this is kind of mainly looking at sort of customers and kind of giving them a better understanding of spatial relationships and visualization of what the part is actually going to look like. So if you have somebody that's interested in buying your product, that is looking at into your product and they want to know, what's it actually going to look like, kind of integrating that with VR will give them a better understanding of that rather than a 3D model where, they might not know the full size of it, the full scale and everything like that. So kind of the biggest thing with these innovations in CAD is allowing the designers to focus on innovation, and creating the best parts, the best products possible. And whereas kind of the other tasks, the more automated ones, the more um, mindless ones can be automated with AI to really speed up how everything is done. Some of the challenges and limitations, there's a pretty steep learning curve to CAD software, and it takes time to train and learn the material. While it's a very powerful tool, not everybody is willing to kind of spend that time doing it. It also costs money for the CAD licenses, as well as getting upgrades every year whenever there's um, new functions, new operations that they do. You always have to pay for the upgrade as well. There's also some interoperability problems. There's a bunch of different companies that have different CAD softwares that all have different file types and they're not always compatible with each other. So if you have two different companies with files and everything, it's not always easy to share them as well. So that kind of adds into sort of the complexity of it, and it's not always easy to go from one to the other. Now I'd like to talk a little bit about why I think I am the expert and why I would want this to be my area of expertise in the future. And it first of all kind of starts with my love for design. I've always loved mechanical design and kind of being able to solve problems creatively. And what I think CAD software kind of opens up is there's so many different ways to solve the same problem and create the same part that it's really kind of like a puzzle that you're working through and you're trying to figure out what the best way is to work with one thing and using all the tools available to you to make the best part possible. Another reason is I'm very comfortable with the software. I'm actually certified in SolidWorks as a professional, so I'm very comfortable with the tools, the shortcuts, kind of how to operate CAD design and really having that uh, state of mind when creating models because it's very easy to get stuck on things. And I've seen people that are just learning it, how easy it is to really not understand. So I'm kind of aware of the common mistakes and some of the tips and tricks. So that kind of makes me more inclined to be an expert in it. Another thing is innovative. This kind of goes back into why I love design as a whole, is really coming up with interesting ways to solve the same problem is something that I love doing. And I think CAD is a great way to kind of exercise that in an engineering environment. Also understanding the power. Understanding why it's useful to spend the time and effort learning this powerful tool because there's so many things you can do with it, in terms of simulations, in terms of visualization of parts, in terms of just creating everything that you need engineering wise that I think everybody should learn. So I'd like to be the expert of it so that way I could teach everyone else how to do it as well, um, and then make their engineering lives easier. Last we have the sources. One is the first one is um, a sort of blog post about kind of where CAD technology is in the world and kind of where it can get to as well in terms of the applications and future innovations. The second is kind of more the history of CAD and an infographic of it and everything as well. So that's all from me. Thank you.